The mole is a unit used to represent a number. Like a pair is 2 of anything. A dozen is 12 of anything. The mole is 6.022 times 10 raised to the 23 of anything. This is also called Avogadro's number, and it is a big number. Every chemistry book has some analogies. Some of my favorites are 1 mole of atoms is more than stars in the known universe. Wrap your head around that. Or if you cover the Earth in marbles, the marble surface would be 50 miles high. These analogies are all cartoonish but necessary, because in chemistry we deal with very small particles like atoms and molecules, and we want to keep track of the numbers of particles. So instead of saying 6.022 times 10 raised to the 23 molecules react, we can say 1 mole of molecules react. Let's discuss where this value comes from. In the 1960s, it was agreed that the isotope carbon-12 would be the standard for defining Avogadro's number. Briefly, we know from mass spectral analysis that the mass of a carbon-12 atom is 1.9927 times 10 raised to the minus 23 grams. If we simply convert exactly 12 grams of carbon-12 atoms into numbers of atoms using the mass conversion, the number of atoms can be calculated. So in exactly 12 grams of carbon-12, there are exactly 6.022 times 10 raised to the 23 atoms of carbon-12. But in nature, carbon will exist as a mixture of different isotopes of carbon, each with its own mass number. When we do calculations, how do we account for these mass differences? In a previous video, we discussed how atomic weights are calculated from the natural abundances of isotopes found in nature. This value gives us the average mass of a carbon atom in nature. This value also represents the mass in grams of 1 mole of carbon. You can go to the periodic table now and find the mass of that element per mole of that element. For example, 1.01 grams of hydrogen is 1 mole of hydrogen, and 14.01 grams of nitrogen is 1 mole of nitrogen. And now you know about the mole.